It's 10:30.
All right, so a couple things. Here we go. I want to go through one of these. This one I think was not doing the right thing on the assignment. I fixed it, but if it marked you wrong, you might have had the right answer. It might have marked you wrong on that one, because I had that one screwed up. I fixed it. If that happens, if you think, it's not going to happen very often. So pretty soon we'll get into not review stuff, and then those are assignments that have been created and they've already been vetted, and problems are pretty bulletproof, but every once in a while, if I'm building them on the fly like this, you might run into one where it has a problem. If that happens, if you're doing an assignment and you think, I'm getting this right, I know I'm getting this right, then don't fight it. Just let it be. I'll make it right. Yes, sir.
Which assignment is this from?
This is 1.5, the last one. So it's solving multi-step equations, but it's the last of the harder one of those assignments. Okay, so this comes from the last question, which is solving a literal equation. So there's a bunch of variables in the equation, and you're going to isolate one of them. So let's go through these steps. How about it? We're trying to solve for h. All right, so you can see that there is a single h right there. So we can isolate it. We can point to a single variable, we can isolate it. So what are the steps? Now, there is no one way to do this, by the way. With these kinds of questions, you could take multiple paths, and I'm not even going to say that one of them is better than the other. There's multiple ways you could get to it. We just want to make sure we can get to an answer. Okay? So there's a couple things as we go through this I wanted to point out. Suggestions here. What could I do? Yes, sir.
Start by getting rid of the threes.
Yeah, you could, sure, you could. That's perfectly fine to do. So one suggestion is, if we're going to work down, we could do some work on the left side of this. We could do some simplifying work if we want to. That's fine. So suggestion, multiply each side by 3. That's good. That works. So if I multiply this side by 3, I get a 3b. If I multiply this side by 3, when I distribute it, what's going to happen? They go away. Okay, yeah, when I slap them right out of there, when I distribute the 3, those all go away. Okay. So does that make sense if I show the work like that? And that's part of what I want to do, is I want to sort of illustrate ways that you can do shorthand work when you're doing your algebra work. So it's efficient and quick, but it makes sense. Okay, everybody good with that first step? Okay, so then at that point we've got 3v equals 4 pi h r squared plus 2 pi r cubed. One point I do want to make, though, we're going to go ahead and clear the fractions, and that's fine. But if we hadn't done that, what could I do with, for example, this term right here, this first term? When I have this separate issue, when I have 4 pi over 3 times hr squared, how can I write that as one big fraction? Good. So when you're multiplying a fraction by something, then that automatically goes to the numerator, right? Because really, we could think of that hr squared as being over 1. So sometimes that's good to do. Sometimes it's good for us to write these as just, make this term one big fraction, that term one big fraction. That also can make things quite a bit easier. Okay. So that would become just 4 pi hr squared over 3. Okay. We're not doing it that way this time, but maybe we'll come back and look at it that way also. So we did a little simplifying. Now what? There's our h. Now maybe we isolate, right? So what's the first step in getting that h by itself? No. If we're because now we're isolating the variable, right? We're going to work bottoms up on our order of operations tree to isolate the h. So what does this prescribe for us for the first step? Okay, good. We're going to add or subtract anything outside of parentheses. Well, there are no parentheses here, right? And so we're gonna push this term that doesn't have the h, the non-h term, we're going to push to the other side. You can almost kind of think about this like chemistry or something, where you're going to try to take the things that are the most weakly attached to that h, and you're going to get rid of them first, right? So here we got this term that's added. Anything that's added or subtracted is pretty easy to undo. That's a pretty weak relationship. So we'll push all that stuff to the other side. Then we've got to undo maybe some stuff that's more strongly attached. We've got to undo the multiplication and division kind of stuff, right? Does that make sense? Okay, so subtract the 2 pi r cubed to the other side. Oops. Okay, so far so good. What's next? Moving up the list. Okay, we're going to divide by what?
4 months.
Okay, so we could divide by 4 pi and then deal with the r squared separately, but why not just divide by everything that's being multiplied by h in one step, right? So let's divide everything on both sides through by 4 pi r squared. Okay? So if we do that, we get our h by itself. Now, something I like to do, and you can be the judge whether you like to do this, but for the honors class, I'm going to kind of model some things I wouldn't always do. But I kind of like to get the variable that I'm isolating alone on the left. You don't have to, but let's go ahead and while we're doing this, let's do an old flipperoo there and put the left on the right and right on the left. So we've got h, that's the technical term for it. So h equals, what about the other side? I mean, that's okay, right? We've got an answer there, don't we? That's fine. You could enter that and you'd get full credit. But sometimes, what if our answer hypothetically had been a little different? Just what if we had gotten instead something like, oh, let's say we'd gotten 6b minus 2 pi r cubed over 4 pi r squared. That would maybe be slightly partial credit because it's not simplified. What's not simplified?
2 pi r and 4 pi.
Okay, so there's even numbers on top and even numbers on the bottom, and the steps to get this thing completely simplified, it involves some factoring, right? And we haven't talked about factoring yet. So I'm going to give you an alternate way. I'll show you the factoring method, then I'm going to show you maybe a safe alternative for now that you could always do when you're simplifying expressions with multiple terms. Does this, don't panic if this doesn't, but does it make sense that I could factor a 2 out of the top?
Yeah.
Remember that? So the top, we could, remember this isn't really our answer, but just pretend. If we factor a 2 out of the top, what are we left with? 3b
minus
cubed, okay, divided by 4 pi r squared, right? Okay, now look, what did that do for us? Well, now we've got 2 factors on the top, and I've got a factor on the bottom. I can reduce like factors and cancel like factors, right? Does it make sense that I could say 4 is really 2 times 2, and so I could reduce that now to a 1 and a 2? Okay. And then I end up with the answer on the top. I just get the 2 is gone, so nothing's being multiplied by this quantity, so I don't even need the parentheses anymore. So I've got 3b minus pi r cubed over 2 pi r squared, and then we'd be done because there are no common factors in the top and the bottom, and that'd be fine. Okay? If you don't want to do the factoring method, there is an alternative, though. We could just say, okay, let's take this original fraction and let's just split it into, instead of having a common denominator, let's just break it into 2 separate fractions, each having the denominator 4 pi r squared. So that would give us 6b over 4 pi r squared minus 2 pi r cubed over 4 pi r squared. And then what that allows me to do is just simplify each one of those separately and get a simplified form also. So over here I could cancel 6 over 4 reduces, correct? So that one becomes 3b over 2 pi r squared. Now over here, there's a lot of stuff going on. 2 over 4 reduces to, thank you, sorry. You got mail. So the 2 over 4 reduces to 1 over 2. What about the pi's? Well, I can't subtract it, but I can cancel vertically, right? They divide away because pi is just a number, just like 2 over 2. So the pi's would cancel. And then what about this? Remember that? That's a property of exponents. Good. When you divide like bases, you subtract the exponents, don't you? So we'd end up with r, the top is bigger, so we'd get r to the 3 minus 2. So I'd end up with then, what would that whole term be? I'd end up with only an r on the top. And on the bottom I would have, I guess, just a 2, right? Because everything else canceled. We canceled the r squared. So that would be my final answer if I wrote them as simplified separate fractions. Okay? Does that make sense?
You want me to go?
What's it say?
It just says.
That's literally what it says?
Yeah.
Okay. It's up to you then. I mean, I think we'll be some time at the end if you want to do it then. Yeah. Okay. Questions? Okay. So for today then, I want to take a quick look at, I almost want to just skip these for you guys. So here's the first linear inequality assignment. Let's just, I'm going to make this really brief. This one, for you guys, this should be nothing. So if they wanted you to do something like this, where you're write an inequality for the graph above, what is that? Okay, so x is greater than 0. We're graphing everything to the right of 0. So we're graphing all values on the real line greater than 0. How come it's not greater than or equal to?
Because that's open.
Okay, because it's an open circle, right? So no big deal. So that's pretty straightforward. So yeah, x is greater than 0. Good. I don't know. Okay, well, that's pretty small. So what about something like this? They want you to, now read the directions carefully here, they want you to solve the inequality. So we're going to write it in its simplest form. Enter r if the solution includes all real numbers, and if there are no real numbers in the solution, you enter in. So what are we going to do here? We're solving a simple linear equality in one variable. How is this different than solving for x in an equation? Right, okay, for one thing, you're going to get an infinite solution set most times, right? Where it's going to it's not just a single point, it's going to be a whole range of values if you graph it, like on that last example, on the real line. Are the rules any different? Not very. Almost everything's the same, but there is one thing you got to be careful about.
Don't if you divide by a negative.
Okay. Okay, if you multiply or divide both sides of an inequality by a negative number, you got to flip the direction of the inequality, right? So what would be, this is a really simple two-step problem. In order, what are the two things I have to do to get x by itself?
Addition and differentiation.
So I got to subtract 8 first, and then divide by -5. Very simple, but we just have to be careful about the direction of the inequality. So if we subtract 8, we're going to get -5x is greater than or equal to 20. And if I divide each side through by -5, on this side I'm going to get an x, on this side I'm going to get a -4, but I have to flip the direction of the inequality. So it would be less than or equal to. Okay? Make sense? Ringing a bell? Okay. And I'm gonna skip up to
Matter of time.
I'm gonna skip up to the compound inequalities. Okay, so what about this? That thing falling apart more?
Yeah.
You might. Oh, jeez. Let's get rid of that one. Why don't you? Let's retire it. Yeah, there's one in the back. All right.
I knew it was gonna happen. I was just
Yikes.
Oh my God. It looks like a lady McMahon.
Okay, let's try one like this. Same instructions, only this time it's a compound inequality. Multiple steps. So let's take a look at this problem. So what does this thing in the middle mean, by the way? Do you remember? Looks like a V almost. That's the math symbol for... No. That's the math symbol for OR. Okay, so that's equivalent to...
I just like the OR.
What is the defining thing that signs it for B?
Just the context. I mean, it is different than, it's kind of, it actually is a little, if I typed a V next to it, you'd see they're a little bit different. Yeah, I mean, I don't know. But it's the context more than anything. Yeah, it's a little bit wider. It's kind of in between a lowercase and a capital, you know, out there in no man's land. So anyway, that means OR. So when we have an OR, compound inequalities, they can be AND inequalities or inequalities. And you got to really, I know that seems really obvious, but there's something profoundly different in the two. If it's an OR statement, that's not very binding, right? If it's an OR statement, that's a lot of leeway. Like, raise your hand if you are male or female in this room. Well, everybody's going to, right? That's going to be everybody. But if we said, raise your hand if you are over 6 feet and you're under 6 feet, you can't do that, right? See what I'm saying? There's nobody that's both over 6 feet and under 6 feet. And both conditions have to be met at the same time. Raise your hand if you're greater than 6 feet and less than 6'2". Right? There's a few people, but not very many, because that's leaving us a pretty small solution set, right? That's going to meet both of those criteria. Raise your hand if you're over 6 feet or under 6'2".
Oh, yeah. Oh, everybody in the room.
Everybody in the room is going to raise their hand, right? Because everybody is either over 6 feet or under 6'2", right? Okay, yeah, think about that one a little bit, yeah. So, what do we do with an OR inequality? And by the way, I'll give you guys the word for this. If it's an OR inequality, we call that disjunctive. It's a disjunctive inequality. So how do we solve compound inequalities that are connected with an OR statement? Remember? Yeah, you work on them independently, and then you just look at the solution set, right? So, like in this case, we're just going to break this into two parts. Let's deal with the left one. Okay, what are the steps to get that x by itself? So I subtract 4. Now what? Divide by -3, which means flip it, I get 4. So there's part of the solution. How about over here? Add 8. Divide by -5. So I got to flip this, right? So there's my answer. Either x is greater than or equal to 4, or x is less than or equal to 1. So it's not 2 or 3 or any of the other real numbers in there that are not integers too, right? So if I were to graph this thing, what would it look like?
The line from the 1.
Okay, so there's 1. So what I'm going to do, if it's less than or equal to 1, I'm going to do a closed circle, right? Because I'm including the point. And then out here at 4, I'd have another closed circle going to the right. So frequently, disjunctive inequalities or inequalities, if they don't intersect, they're like the oars on a boat. Like you're looking at a boat coming at you, and those are the oars, right? These are your numbers. Okay? Let's try another one. Okay, let's try. All right, what about this? Okay, so if we got, this is an and inequality, right? And inequalities are always written in three parts. If it's an and inequality, that's what we call a conjunctive inequality. In math circles, we call it a conjunctive inequality. How would we read this? Somebody want to take a stab at reading this correctly? Yes, sir.
20 less than or equal to negative 5x and 10 less than or equal to negative. Oh no.
Okay, you're, appreciate the effort.
I know.
You got us going. You got the ball rolling. That's good. Yes, sir.
20 less than or equal to negative 5x plus 10 and negative 5x plus 10 is less than
Closer. Anybody want to see if we can get it right on the, right on the head here? What do we got? What do we got?
Mercy.
Okay, go ahead.
Okay. Negative 5 plus 10.
Negative 5x plus 10, you mean?
Negative 5x plus 10. Less than or equal to 30 and greater than or equal to 20.
Okay, that's
Or
about,
the other way around.
that's 99.9% correct. So here's how you would do these things. Yep.
Still room for.
Negative 5x plus 10 is less than negative 30 and greater than.
Okay, I think that's the same thing.
You
No,
just
it's
take
just
equal
the
to.
other
Oh.
Acceptance, I
Okay. So here's how we would tend to do this. When we say that sort of the etiquette in math, well, the protocol we would take in math is you always start with what's in the middle, right? And this is the most efficient, the briefest and the most efficient, and probably the most accurate way of saying it. So negative 5x plus 10 is greater than or equal to negative 20 and less than or equal to negative 30. So it's going to give you an interval on the number line. Now that's a little weird. So how do we solve these things? I know these people are getting some quizzical looks. It'll all resolve itself in a second. How do we do algebra on a compound inequality?
Well, we do one at a time.
We actually can treat it all at once. So our goal is to isolate the x, right? So when we isolate the x, now you can already tell me, what are the two steps in order to get the x by itself? So we're going to subtract 10, but instead of subtracting 10 from both sides, we're subtracting 10 from all three parts, right? And then we divide by negative 5, but we divide all three parts, right?
Wait, so,
Go ahead.
but you still do the switchy thing, right?
Yeah, right, we still do the switchy thing.
So then
Exactly.
can you just like switch around your whole?
You do, exactly.
Okay.
And so we'll see that. So step one. Step one is we're going to subtract 10 from everything, right? So that leaves us with 10, negative 5x, and negative 40. Everybody agree? Step two. We're going to divide everything by negative 5, right? Which leaves us with negative 2x and positive 8. And that means we have to flip around the inequality signs. Okay, but here's what Kendra was asking about, and this is good. That is not the way we want to leave this thing. We always want to write it like it would be on a number line. So we want to write it with the smallest things on the left, so we got a less than or equal to there, and a less than or equal to there, right? Does that make sense? So we want to take this whole thing, and imagine I've like written this on a glass slide, and then I take the glass slide and just do that with it, right? So it's going to get completely flipped around. So the 8 goes over there, the -2 goes over there, the x goes in the middle, and then those get dragged around like that, right? Okay, good answer? Good answer? So all values of x greater than or equal to 8 and less than or equal to -2.
I would write it in a little bracket.
We could, say it again?
Write it in those little bracket.
Yeah, we could write it, and we'll talk about different notes, so you talk about interval notation. We'll get to that. Anybody see something wrong with this?
Greater than
Well,
eight.
it makes no sense. How do you?
It makes no
there's
sense.
number?
No.
Yeah.
That should be, yeah. 'cause
That's impossible to do, isn't it? How can a number be both greater than or equal to 8 and less than or equal to 2?
Can't be.
Can't be. So the answer is no solution.
On a number line, would you just put a dot, like technically you could represent it by putting a not filled in dot.
No. Well,
Because then you put that anywhere and it's not
Oh, on
that
a number
spot,
line?
it's not any of.
Yeah, but I mean, it'd be, honestly, you couldn't even really represent it. Okay, let's do one that you can, though. I'm gonna make one up. So you guys, try this one. Try this in your notebooks here. How about if we have, okay, quickly try that. Yes, ma'am.
Inequalities that have variables on either side, so like not in the middle, but on the outside.
No, we're not going to for now. No. If you did, you try to move them all into the middle. It just, yeah.
Try to say it.
Okay, so what are the two steps in order? That part's easy. Subtract 7 and then, no, divide by -3. Okay. So you do this and just kind of check and see if you're getting the same thing I'm getting.
You have a circle on one side or dot on the other. That's fast. What are you? You know what
Oh, it's negative. It is?
Everybody get that?
Oh,
Everybody get that?
Yeah.
Okay, so but that's not, I don't want to write it that way. I want to write it like a number line. I want to put the lesser value on the left, the greater value on the right, just like a number line. So my question is, what does that look like when I flip this thing around? -1.
crocodile mountain, X.
Okay, X, and
5,
what symbol's going to go there?
less than,
Okay,
less than.
there you go. Make sense?
Very well.
So everything just got flipped around completely, right? This guy has to go there, he has to go there and get flipped. Okay? All right.